Hello students, as you know we are doing chapter haloalkanes and haloarenes. So in today's topic we will study about the nucleophilic substitution reactions of haloalkanes and haloarenes. Before starting this topic I want to share a story about true friends and fake friends. Once there was a boy, Raju. Raju was 10-year-old and was studying in class 5. He was very innocent, jolly and honest boy. He always liked to have friends and talk to them, share his thinking with his friends. He was very kind and helpful toward his friends. His father was a policeman. Once Raju had to change his school due to job transfer of his father to a new city. So, in his new school, Raju was able to make some more friends to him. Out of these friends, two were Ravi and Rahul among his new friends. After a few days, Raju realized that Ravi is not a good friend as is a selfish boy, whereas Rahul is a very good friend and is always ready to help him. So, in the meanwhile, he also mean and selfish. He used to be good to someone when needs some help. But when Ravi finds someone other more useful to him, Rami immediately leaves his old friends and tries to get close to the new persons. Not only this, he was also had habit of spreading negative rumors about his friends and usually insults old friends in front of his new friends. Due to all this, no one liked to be his friend, hence no student in the school stays in friendship with Ravi for long time. On the other hand, Rahul was very kind and helpful friend. He used to provide his own things to Raju when he needs. Whenever Raju is in any trouble, he asks Rahul for help and Rahul tries to support him emotionally and help to overcome negative thoughts. So both of them remain together as much as possible, and it helps both of them to have overcome their problems and enjoy their togetherness. So this story of true friends and fake friends can be used to understand the concept of nucleophilic substitution affection of alkyl halides and aryl halides. We know that in a nucleophilic substitution, like in case of alkyl halide, halide ion leaves as nucleophile and a new nucleophile like here shown hydroxide ion, which takes the place of halide ion. So we can see here the bromide ion is replaced with hydroxide ion and we get an alcohol as a substituted product. So alkyl halides easily undergo such nucleophilic substitution reactions as compared to aryl halides. Now why it is so? So we can compare this more reactivity of alkyl halides towards nucleophilic substitution reactions as compared to that of aryl halides to this true friends and fake friends stories. So we know in case of aryl halides, nucleophiles is halide ion which is to be replaced with some new nucleophile. Halide ion acts as nucleophile. It has 3 lone pairs of electrons. So in aryl halide, the CCl bond, or we can say CX bond, carbon and halogen bond, due to resonance acquire more strength and become shorter. So these bonds are not broken easily and nucleophilic substitution reaction becomes difficult because to replace halide ion we first need to break the CX bond, that is carbon halide bond, which is not easy. See, we can see in the diagram also that due to resonance in chlorobenzene, which is one example of haloarine, the lone pair of chlorine is shared by arene, that is aryl ring, so that the shifting of this pair of a lone pair of electron between C and Cl bond makes it double bond. So in the diagram number 3 we can see there is a CCl double bond due to resonance, and pi electron pair in the benzene ring shifts to next carbons as lone pair, and we can see this in turn goes on changing from position number 2, 4 to 6. So we can say in aryl halide, halogen atom shares its electron pair with benzene ring. Benzene helps to stabilize the molecule by making CX double bond, which is stronger bond, but it is not a true double bond. In resonance we can see 3 structures have double bond but 2 have single covalent bond, so means in between, that is partial double bond character exists between CX bond, and we know that double bond is shorter than single bond. So we can say due to resonance in case of haloarenes, aryl ring shares the electron pair of a halogen atom, which makes the entire molecule resonance stabilized. Hence it is not easy to cleave CX bond or break CX bond to replace haloid ion with some other nucleophile. So that makes aryl halides less reactive towards nucleophilic substitution reactions. So chlorobenzene, when we compare it with chloroethane, which is an example of alkyl halide, so there is no resonance, but rather than resonance there is plus inductive effect of aryl group, alkyl group. So due to this positive inductive group effect of alkyl group, electron density on chlorine increases, it becomes polar and easy to break. So hence in case of alkyl halide, no sharing of electrons by resonance, so no stability increase due to resonance, but there is decrease in stability due to shifting of electron pair or electron clouds from electron density from alkyl group to halogen atom. That's why alkyl halides can easily undergo different types of your nucleophilic substitution reactions. We can see in this diagram, like with aqueous NaOH it changes to alcohol, with sodium alkoxide it changes to ethers. It also undergoes reaction with KSH to give alkyl mercaptans. Similarly it reacts with amines to give primary amines, secondary amine or tertiary amines. With cyanides it gives isocyanide or nitrile compounds. AgCN it gives isocyanide, with KCN it gives a nitrile, alkyl nitrile. So same way we can also see halogen exchange reaction when iodide replaces the halogen atom, and when we react with sodium nitrate it gives a alkyl nitrate or nitroalkanes. But to react chlorobenzene with aqueous NaOH to convert it into phenol, it is not easy because of double bond character between C and Cl in case of chlorobenzene. Hence we need to use very high temperature and high pressure to carry out this reaction, so which further shows the less reactivity of haloarenes or aryl halides towards nucleophilic substitution reactions. Thank you.